this is the architecture which my CloudFormation template will be bringing up. Okay. So this CloudFormation template is a production ready cluster. So how it is going to bring up is, so we are going to have a cluster which is going to come in on a private subnet. Okay. In Amazon, there is a concept called a VPC. Okay. You can create a particular network. Okay. In that you can have a subnet and private subnet. Okay. So in the real-time example, I told normally the web servers will be put into an area where it has a public IP, but the app servers and DB servers will be putting it in a private subnet. Okay. So a good production cluster should be running in a non-public environment. Okay. And the API service only needs to be exposed to the external world. That is the best practice this CloudFormation is following. So basically, I'm going to create a VPC. Okay. And in the VPC, there will be two subnets created, and the Kubernetes cluster will be brought up in a private subnet, and this will have a master server. Okay. And the nodes will be there in a auto scaling group. That means whenever the node mission CPU goes beyond a particular range, okay, this will automatically add nodes to the cluster. For example, this is where the real-time scenario comes in. When you add more containers to the cluster, it needs more compute and more memory, right? In that case, we are using the Amazon auto scaling functionality to automatically add nodes to the cluster. Okay. And this Kubernetes master will be exposed to the external world using the load balancer. Okay. And I need to connect to the machines, right, to do the troubleshooting and stuff. For that, I'm having a based-on host or a jump host. So if I want to access any of these servers, I'll be connecting to the jump host first, and then I'll be connecting to here. Okay. So this is the complete infrastructure we are going to bring up using a CloudFormation template.
Yes.
Okay. Now, in the search bar, search for CloudFormation. So you will see option called CloudFormation. Click on that. So CloudFormation is an infrastructure as a tool for Amazon, okay, where you can write the complete infrastructure as a code, okay, and this is basically written in a YAML format, okay, where all the resources which I shown in the diagram, right, I'm going to, we have written that in the YAML format. It will create a new VPC. Inside that, it will create the subnets and bringing up the server, and then in the server configuring the Kubernetes cluster, all those things you'll be able to do that. Okay. So in the CloudFormation, you will see a page like this. Click on the create stack. Okay. Let me repeat. In the CloudFormation page, click on create stack. And so this is where it is going to allow you to upload the CloudFormation YAML file. You can just say the template is ready, and in the upload a template file, just choose it and select the YAML file, and then click on next. So let me repeat, the template is ready, and upload a template file and click on next.
Yeah, on this page.
Yeah. Okay. Then in the stack name, give your trainee ID. So I'm going to call it as batch 1. Okay. So in the stack name, give your trainee ID. And in the availability zone, select the first one. In the admin ingress location, put this value 0.0.0/0. That means this is where I'm telling from which IP I should be allowed to connect to the API. So I should be allowed from any IP. So that's why I'm giving 0.0.0/0. And in the SSH key, in the drop down, select your trainee ID. Okay. So let me repeat the changes. In the stack name, put your trainee ID. In the availability zone, select the first one. In the admin ingress, put 0.0.0/0. And in the SSH key, select your trainee ID. This is a drop down. And then these are all the IP ranges for my network. What should be the VPC IP range? What should be the private subnet? And what should be the public subnet? Okay. And what should be the network provider? DNS provider. And what should be my network provider? Here note, we are using Calico. And the node capacity 2 MIDs. It will bring up 2 nodes. Okay. And the instance type is T3A medium. And disk size 20 is enough. Not need more than 20. So just reduce the disk size to 20. And instance type is for the based on host. So this is the instance type for this jump host. What is that? So this is T3A micro, and these are predefined parameters. Okay. So this is the region from where it is going to download the kubeadm and all the binary files. It's going to download it from this location. So once you provided this information, click next. Okay. In the next page, you don't need to do anything. Okay. So in the next page, no changes. And in the last page, you need to acknowledge both of them. Ensure that you are acknowledging both of the option, and then click on create stack. So this is going to take at least 5 minutes to complete the creation. Let's wait for that. So once it is completely up, I will show you what are all the resources it is creating. Check it here. So normally you will see it is going to create one more stack in the background. You will see that. Let it complete, then I will show you that. So I'm back. So there is one more stack that will be created in the background. So I'll show you once it is done. So by the time there are services like VPC would have been brought up. Let me just show you those. So this is my region. So you can see there is a VPC has been created, right? In the VPC, there will be 2 subnets could have been created. One is called as a public subnet and another one is called as a private subnet. There you can see this is under this trainer VPC. And when I mean to say a public subnet, there will be internet gateway need to be attached for the internet connection for assigning the public IP and internet connection. And it will have a NAT gateway that will be created, because when I bring up a machine in the private subnet, to have an internet connection for the machines in the private subnet, I need to have a NAT gateway. So it is going to create a NAT gateway for me. And then it is going to create a route table for that also, because whenever you create a subnet, you need to have a route table created. So those things you can see it here. And by the meantime, it might have created a missions. Okay, so it is bringing up the master. Okay, it has brought up the master and also the jump host. Okay, and then it will be bringing up my node, the create in progress, and in that it might have created a auto scaling group. So this will be creating the auto scaling group, so in which my nodes will be coming. Okay, it is not yet created. Let's wait for it to complete. And we should see a load balancer might have been created by now. Yeah, there is a load balancer is getting created, and that will be pointing to my master instance. So in the master only, I will have the API server running. So it will be pointing to that. So let them come. Once they come up, I should see that they are in service. So you can also see the events. If you refresh the page, you can see what is happening in the real time. So the master instance creation is in progress now. Yeah, master instance is created. Okay. Now it is going to create a node group. So this is where the auto scaling groups will be coming up. So if I see the auto scaling group, so there is an auto scaling group coming up. It is saying the number of instances should be 2. By the time my load balancer could have been come into service, you can see previously it was out of service, now it is in service. And if I go to my EC2, I can see 4 instances it is getting created. So it is bringing up the node and it will be attaching it to the master. You can just see this here. So we'll come back, still in create in progress. Okay, mine is completely created. You should see a create complete here. Okay, and to show you about the auto scaling group, okay, there will be a launch configuration that will be created. In the launch configuration, I can see the kubeadm join command is given there. So this is my launch configuration. So in that, there will be option called user data. Okay. In the user data, I'll be running the kubeadm join command. Okay. That is what is being configured here. So this is the user data. You can see. Okay. This is what it is running to send the initialization of the cluster. You see the instances for your trainee ID. Okay. So you might see all the missions there. So you can just filter with your trainee ID. Okay. With the key name, you should be able to see that. There you can see the informations. Okay. So once the CloudFormation is done, if you go to the Outputs tab, you can see a couple of these informations. Okay, so this is the command to join the node. Okay, my major thing is here is like I need to get the public IP of the node. Oh, sorry, in this one. So you should go to the actual CloudFormation, not the nested one. If you go to the outputs, you can connect to the machine using this IP, and from there you can get the config file. So let's do that. Now the cluster is up. Okay, if you select the primary CloudFormation stack which we created, if you click on the output tab, you can see the informations to connect to the server and get the kube config file. Okay, so let's do that. So for that, let me open up my putty session. Okay, in the putty, let me get the based on host public IP, and then give the host name, and from there I can select my key and then connect to it. So this is my key, and the username for this is Ubuntu, because this CloudFormation template uses Ubuntu as my image. So first I'm connecting to the based on host as I shown in the diagram. First I'm connecting to the based on host. From there I'm going to connect to the master, and from there I'm going to get the config file. I need to copy the key file onto the server, because only with the key I'll be able to connect to the master. So the initial zip file which I shared with you is having a PEM file. You are going to copy the content of the PEM file. So if you see the zip file, there will be a PEM file in it. Just open the file on a notepad. And copy the content, the complete content, and there let me create a file dot key dot pem. So let me create a file called key.pem and copy paste the content of your respective PEM file. And then the PEM files should be readable only by the owner. Okay, so let me apply that using the changing the permission chmod 400 key.pem. So this will change this is a security requirement in SSH. The PIM file should be readable only by the owner. So once you change the permission, let us go to the CloudFormation stack. There you can see get the kubeconfig command. You can see a Ubuntu @ 10.series IP. Just copy that. So Ubuntu @ some 10.series, the IP will be different for you. And there you can say ssh-i key.pem and Ubuntu @ you may get a prompt like this, type yes. So now notice that you are in the 10.series machine. So from the jump host, I'm connecting to the master server. And there, if you read the content of kubeconfig, let me just read the content of this file. Sudo cat. So I will see this. So just copy the complete content starting from the API version till the end of the line. Okay. Now open your command prompt. I'm just opening my command prompt. There, by default, you will be in your home directory. When you open a command prompt, you'll be taken to the user's home directory. There, run a command called, let me just give you this command. And then I will just sudo cat and then give the command mkdir.cube. So why I am doing this in a command prompt means in Windows that you cannot create a directory starting with dot, but kubectl looking for the directory which starts with .cube. So you have to create it with the .cube extension. Sorry, .cube should be the folder name. Run the command on the command prompt, run mkdir.cube. And once it is done, go inside the .cube and then give the command notepad config. So I have an existing file, but that's okay. For you, it will open up a empty notepad. In the empty notepad, paste the content, copy paste the content from the putty. So while copy pasting, ensure that you are in the full screen mode. In putty, don't open it in a minimized mode or cropped mode. Keep your putty in the full screen mode and then do the cat of the file. And then once again, once it is printed, select this, starting from the API version till the end, and put it inside this and paste it here and just file save. That's it. So here I'm downloading the configuration file from the master and storing it on my local Windows, because I'm going to use my Windows to bring up the deployment and all those stuffs. So if you see the output, you can see this is my private IP of my master. So once you are done with the copying the config, download the exe file onto your Windows. So let me come out of this directory. So in the Windows, I'm going to come to the home directory. There, I'm going to do a make directory training. So all the YAML files, I'm going to put it inside the training. So let me create a training. I already have a training folder. Let me just leave it as OS batch 1 training. So you can make a directory called training. If you already have a folder called training, just name it whatever you want, and then go into the training directory, and there, okay. So let me go to the downloads where I downloaded the kubectl exe, and I can go to my directory and go to the directory and paste the kubectl.exe here. And once you pasted it, if you run the kubectl get nodes, you should be able to get the cluster information.
Yes, indeed.
So let me show it on the Explorer itself. So basically this is my home directory. There I have created a .cube folder. In the .cube folder, I have stored the config without any extension. And then I have created a directory called training. Inside that I have kept my kubectl exe. And here I'm running the kubectl get nodes command. Okay, great. So let me run this command. So in the cluster, I want to see what are all the pods which are running. Okay, so if you see that I have a 3-node cluster. So I have my Kube API server, control manager, my etcd, okay, and 3 proxies are running, 1 proxy per mission, because I have 3-node cluster. So I have 3 proxies running, and I have my Kube scheduler running, and also I have 4 Calico, sorry, so 3 Calico containers, and Calico also uses etcd. So there is a separate etcd for Calico, and then for Calico I need a controller. So I am having a controller for the Calico also. Okay, so these are all the various containers running, and adding to that, this cluster is having a dashboard pre-deployed. They have created a namespace called Kubernetes dashboard, and inside that I have my dashboard pre-installed. So let's see, how do I connect to the dashboard from my Windows machine? Okay, so basically kubectl provides a mechanism called proxy. By using the proxy method, I'm going to connect to the dashboard. So let's see, how do I do that? So first, in this command prompt, run the command kubectl proxy. So it will start to serve on your local machine on port number 8001. Okay. So when you run the command prompt will be logged and it will be serving on the 8001 port number. And let me open up a browser. Okay, here please use Chrome or Firefox. Kubernetes dashboard doesn't work well with your IE or Edge. Okay, there I'm going to put the URL. So I need to make some changes here. I'll give the URL to you. Okay. So access this URL from your browser and it will be asking for a token to connect to that. I will give you a command to get the token.